So today we are going to discuss about the light reflection and refraction, the two important phenomena of light. We know that light is a form of energy which enables us to see the things around us. The light exhibits the two important phenomena are reflection and refraction. So we know that reflection, something, the light falls on the object, any smooth surface, it reflects back or it bounces back. Or the phenomenon of refraction, the light changes its direction as it passes through a substance or passes through an object, a transparent object. So the light has dual nature. Then what do you mean by dual nature? The earlier it is thought to have, the light has thought to have a wave nature. But later on it is believed that the wave nature of the light was not enough to explain the interaction of light with matter. Then another theory came into existence, that is the particle theory of light, or the light exhibits the particle nature as well. And later the quantum theory of light came into existence, and it is believed that light is neither a wave nor a particle, but it reconciles that the particle properties of light with wave nature. And here now we are going to discuss the two phenomena, reflection and refraction. And first we are going to discuss about the reflection of light. Then what do you mean by reflection? If the light incident on a smooth surface or highly polished surface, it bounces back or it reflects. And the reflection, the amount of light that reflects depends upon the smoothness of the surface or how the surface is polished. If the surface is highly polished, then the maximum amount of light will be reflected. And if the surface is dull or irregular, then the reflection or the amount of light that reflects will be less. So reflection is an important, and we know that many devices or many devices that reflects the light, and these two phenomena of light help us to explain the various phenomena in the nature, like the formation of rainbow and the bending of light as it passes through a medium, and all these phenomena helps us to explain. And now when we discuss about the reflection, then we need to understand the two laws of reflection. And whenever the light incident on a surface or smooth surface, and the light reflects as per the laws of reflection. There are two laws of reflection. One, the laws of reflection, one says that angle of incidence is generally denoted by a letter I, is always equal to the angle of reflection. That is generally denoted by the letter R. And second law says that incident ray, reflected ray, and normal all lie on the same plane. So these are the two laws of reflection. And when we see these two laws of reflection, here these two few terms we can see: incident ray, reflected ray, normal, angle of reflection, and angle of incidence. And let us understand what are these terms. So, see, this is a surface, a smooth surface in which the light incident. So here we consider a ray of light. This is a ray of light, and then this ray of light is coming from a source and incident on a point on this smooth surface, and the one side of the surface is smooth and the other side is rough. So the rough side of the object will be can be represented or can be expressed like this. See, the light which is coming from a source and then it is incident on a point. Okay, here this is the point where this incident ray falls on the surface. So this incoming light is known as incident ray. So as we know, as we discussed earlier, if a light is coming from a source, incident on the surface, a smooth surface, definitely it will reflect. So then the light that reflects back, okay, and these arrow marks shows the direction in which the light incident and the direction in which the light reflects. So the ray which is coming from a source is called incident ray, and it is incident on a point on the surface, and this point is known as point of incidence. And then the ray which is reflected after hitting on the point of incidence, and this ray of light is called the ray of, or the reflected ray. And the plane or the surface, entirely we call it the plane of incident reflection. And if we draw a normal or a line which is perpendicular to the plane of incidence, okay, this is the plane of incidence, and if you draw a line which is perpendicular to the plane of incidence, and then this line is called normal. Normal, we asked already, we know that this is a perpendicular to a surface. Perpendicular means that makes 90 degree with the surface. Now here we can see this incident ray and reflected ray. These two rays are making an angle with the normal. Okay, so the angle that formed between the incident ray and the normal, this is the angle that formed between the incident ray and the normal, and this angle is known as angle of incidence, and which is generally denoted by the letter I. And there is another angle that is formed between the reflected ray and the normal, and this angle is known as the angle of reflection, and which is denoted by the letter R. So angle of incidence, angle of reflection, then point of incidence, normal, incident ray, reflected ray. So these are the terms when we discuss about the or general terms which is associated with the reflection. And now let us see. The first law says angle of incidence is always equal to the angle of reflection. That means the angle formed between the normal and the incident ray and the angle formed between the reflected ray and the normal is always same. That is the first law says. So that means what? If a ray of light is incident on a plane surface, a smooth surface at an angle, then if the surface is smooth, then at the same angle the light will reflect back. So that is the first law. suggest. And second law, incident ray, this is the incident ray, reflected ray, this is the reflected ray, and this normal. These all are lie on the same plane. Okay, that is generally we terms associated with the reflection. And now, so when we talk about the reflection, then there are different various devices or surfaces that reflects the light. So generally we know that mirrors reflects the light. And what is a mirror? Mirror is a highly polished surface and or highly smooth surface, and the other side of the mirror is rough and which is polished by an opaque or paint or something like that which does not allow the light to pass through. So mirror generally reflects the light. Since the one side of the mirror is highly smooth, then a mirror reflects maximum amount of light which falls on it. Then when we talk about the mirror, there are different kinds of mirrors. Plain mirrors are there. Plain mirrors, we know that the mirrors generally we use at home for shaving or to see our faces or makeup mirrors and all. And then another kind of mirrors are spherical mirrors. Then what are spherical mirrors? Spherical mirrors are the mirrors which also reflects the light, but they are spherical in shape. Spherical in shape. Why? Because it has an aperture, or it is a part of a sphere, and that reflects the light. Depending on the shape of that mirror, the spherical mirrors are of different. They are concave mirrors and convex mirror. Then what is concave mirror and what is convex mirror, and how we can differentiate or physically, or how we can differentiate them, or how we can recognize them. So the concave mirror and convex mirrors can be recognized by their shape. So both are spherical, is a part of a sphere, a small piece of a sphere, and which is in the spherical shape, and both the mirrors reflects the light, but they are different in terms of their reflecting surfaces. And how they are different? A concave mirror, okay, spherical in shape, but the reflecting surface of a concave mirror is bent inwardly. So that means what? The smooth surface is bent inwardly, and this is the rough surface of the mirror. And a convex mirror, and the reflecting surface of the convex mirror is bends outwardly. Okay, so this is the reflecting surface of, the rough surface of the mirror. So here see, the reflecting surface of a concave mirror is or bends inwardly, and the reflecting surface of a convex mirror is bent outwardly. So this is by the shape, this is how we can differentiate them or recognize them by their shapes. And these two spherical mirrors are then reflects the light in two different ways. And on the basis of the way in which they are reflecting the light, they are known as converging mirror and diverging mirror. And how does it happen? So we know that since the reflecting surface of a concave mirror is bends inwardly, so the light that falls on the concave mirror, and they will converge at a point. Okay, and which rays converge at a point and which rays reflect back, or whichever may it may reflect back, but the reflecting the nature of the reflection also different. So whichever may, then it will reflect, or this concave mirror can converge the incident rays at a particular point, and therefore the concave mirrors are known as converging mirrors. Then what about the convex mirror then? Convex mirror, most of the rays fall on the convex mirror. They diverge, that means it moves away from the mirror after reflection. Therefore, a convex mirror is always known as a diverging mirror. Then, so these are by nature, the mirrors, spherical mirrors are different. Now, before we are going detail about the reflection and the spherical mirrors, and we need to understand some of the terms associated with the spherical mirrors. So, the terms associated with the mirrors, and these terms are common for both concave and convex mirrors. So, this is a spherical mirror. So, let us see a concave mirror, and this is the rough surface of the concave mirror. And now, a piece of a spherical sphere, then if I extend this both side of the sphere, then it will produce a sphere. And if it is a sphere, then the sphere must have a center. And this center of this sphere, imaginary sphere, that is the center of curvature. Okay, it's denoted by C, center of curvature. So that is the first term, center of curvature. Then, so in this spherical part, a piece of sphere, it has a midpoint, and that midpoint of this spherical mirror, and that is known as pole of the mirror. And then now the second term is pole of the mirror. Then the distance between the center of curvature and the pole of the mirror, that is a distance. There is only one ray, or there is only one line can pass through, or one line can connect this pole of the mirror and the center of curvature, and then this line is known as principal axis. Principal axis of mirror. Now, the distance between the pole of the mirror and the center of curvature, and that is known as radius of curvature. Now, center of curvature, pole of the mirror, and again principal axis, then radius of curvature. And assume that since this is a concave mirror, some light rays, okay, these are some of the light rays, then these light rays are incident rays which are parallel to the principal axis. We consider only the parallel rays to the principal axis. So obviously we know after hitting on the reflecting surface, these all rays will reflect. Then these rays will reflect. After reflection, all the rays will reflect back through a single point. Okay, single point on the principal axis, and this point is known as the principal focus of the mirror. All the reflected rays are, since it is a converging mirror, these mirrors are converge at a point on the principal axis. And what if it is a convex mirror? Then convex mirror is a diverging mirror. So since it is a diverging mirror, these light reflected rays will not converge at a point. It will be Likewise, C pole, and again we consider some of the parallel rays which are parallel to the principal axis. So this will reflect likewise only. It moves or reflects away from the principal axis. So then how we find out the principal focus? But after reflection, if we extend these reflected rays in backward direction like this, if we extend the principal axis too, these reflected rays appears to converge at a point behind the mirror. Okay, then this is the principal focus of a convex mirror. Okay, so we can say that here these rays are converge really at a point on the principal axis. So the principal focus here is a real focus. But for a convex mirror, these reflected rays appears to converge a point behind the mirror. It is not a real point. So therefore, the principal focus, the focus is not a real focus for the convex mirror. So this is how these two mirrors reflects the light. And so the fifth term is principal focus. Then sixth term, that is the distance between the pole of the mirror and the principal focus. This is the distance, right? And the distance between the principal focus and the pole of the mirror, and which is known as the focal length of the mirror. So the sixth term, focal length of the mirror. So these are the terms associated with the mirrors. Center of curvature is generally denoted by the letter C, and pole of the mirrors generally denoted by letter P, and principal axis, then radius curvature is generally denoted by the letter R, and principal focus is denoted by the letter capital letter F, and focal length is generally denoted by the small letter f. So these are the terms associated with the mirrors, spherical mirrors. Now, so we know that the spherical mirrors reflects light. And what does it mean? So after reflecting the light that falls on a mirror, so it forms the image of an object. So that is the main aspect, right? So it forms the image of an object. Then how does a mirror forms the image of an object? So that is we are going to see, or we are going to discuss about the image formation of the spherical mirrors.